Okay, hello everybody. It is the first session of the Holochain-in-Action with my lovely friends from a community. Warm welcome everybody. So we already did check-in. We are not going to make it really busy with the check-in time. So right now we are going to jump into the first session. For the beginning, I am going to implement and pair programming with you the PeerShare in action. And I'm going to jump inside to the definition of a PeerShare. What does it mean? What is the architect and what we are going to do? So PeerShare for me, it is kind of experimental practice and somehow some pattern, design pattern or architecture introduction for the Holochain application. So it means we are going to practice together. We are going to share our knowledge to see where we are going to land. So if something is not clear at the beginning or we are going to change something, it's totally practical. We are going to build step by step. So it is the whole topic of the PeerShare that I'm going to start. And after that, any other application can warm welcome. We can continue for the other session. So that's it. Is there any question or I can start? That is great. I'm going to share my screen. Do you see my screen? That is great.
Yep.
So it is the design and architect of Holochain PeerShare actually.
Sorry, is it the same for everyone else that I have two big squares in the middle of the screen? Yeah. I think it's the zoom overlays. The zoom overlays sometimes may do that, Hedayat.
Zoom.
So in your screen, we saw boxes, gray boxes.
Okay, maybe it was about the. Okay, let me. What do you see? Right now, nothing. Yeah, let me see desktop 1 and desktop 2. I have to monitor. Okay, let me see. Is that okay? This no. Let's see. Do you see?
That's perfect. Perfect.
That's good.
That is great. That is great. Yeah. PeerShare. As I mentioned, it is totally experimental. And what is in my mind for the PeerShare? Let's see what I would like at the end to introduce. It is kind of architecture and pattern to implement Holochain really fast and really practical and without actually by reducing some concern. What does it mean about the concern? As you know, if you design holochain DNAs and if you are going to do some changes, as soon as you do some changes, the DNA code and zone code, so immediately you're going to have a different hash, so you need to go to the next version. There are some concerns, there are some ways and solution for that for sure, but if I was thinking if we can have a solution or a practice at the top, so it can make it much more easier. That's why I ended up to this basic architect to design PeerShare in that way that I'm going to explain. Two, my reason is here, as I mentioned. I'm going to share this PeerShare, this GitHub, and we are going to continue this one. Generally, in the PeerShare, my main reason that to implement DevOps, that we can continuously deliver the next version of application without a lot of versioning, a lot of concern actually. Hybrid solution means Oracle problem that we strongly have it inside the blockchain. So it's really hard, it's not easy to go for the centralized architecture called API. It's not easy. One of the purpose or reason behind the scene for designing PeerShare is implementing Oracle or hybrid solution. Modularity, you will see GM Others implemented a bunch of modules inside GitHub Holochain Open Dev that I will share the link. So if you are going to use one module, I'm going to use a file share that GM implemented that to demo modularity. And then interesting topic that how we can design application which is compatible with the HoloPort. Mostly we are going to postpone this topic to the end. So it is interesting topic. And during this process, there should be some architecture patterns, and we are going to introduce. For sure, it's going to be the version 1. I just put version 1 to see what's going to be at the end, and maybe we can continue to version 2, improve it, or let's see. It is experimental. So, as you can see here, briefly, I am thinking to have Holochain application in 3 layers. I'm calling it layers. Holo layer, outlet layer, external layer. Holo layer, I mean everything about the DNA zone. It means Holochain application. That's it. Everything about the Holo layer, all design Holochain application is going to go there. Outlet layer, I'm not calling a UI layer, and I will explain later because I believe a UI is part of outlet layer. So, which is mostly MVC pattern. So it means the consumer or the app that mainly the user can see, but the UI is part of it. The connection to the DNA, connection to the outside or Oracle issue. Let me explain here. It's going to be actually Holo layer that we are going to start today by a little bit pair programming. And then outlet layer here, which is the MVC pattern. In the outlet layer, view is just the UI. So the outlet layer, because the paradigm is a peer-to-peer application, we don't have any more the centralized architect that is request and request that we are not going to see in the old traditional fashion of serving some request or something like that. So the way we are thinking here, it should be a little bit different from my idea. So, and that's why I'm calling outlet layer. In the outlet layer, controller, model, and MVC actually, model, controller, and view. So in the controller, connection to the DNA conductor, DNA adapter, or signaling to conductor or signaling other peers is going to be in the controller, and also Oracle adapter. It means calling outside of the outside. It means any application, centralized application, or even calling a MetaMask to go to the blockchain layer, do a payment, anything. Everything's supposed to be in a controller. Model, it is the way I'm designing PeerShare, I'm going to explain right now, and a view that it is showing. So it's going to be outlet layer, and then external layer, as I explained here, everything can be external layer. Maybe I'm thinking for a demonstration actually to show we are going to implement something like maybe a PayPal payment, maybe Elasticsearch. We are going to have indexing inside the Holochain for sure. We need to design. We already discussed internally with other developer, timing indexing, blah, blah, blah. But generally also to show how Oracle can be implemented inside Holochain application. We can also implement Elasticsearch, for example, just for a demonstration. It is just 3 layers generally that I would like to introduce by implementing PeerShare. There is another part, what does it mean about the abstraction, each layer that I'm explaining here. But before that, if there is any question, I can answer, please.
Yes, I have a question here. Is it possible to take a step back from your architecture And briefly, the PeerShare. What is the idea for people, for the usage? Your microphone is cut.
Okay, I got it. Yeah, that is really good question. I should have started from this one. PeerShare, it means at the end, it's supposed to be application that people can share file or some text file, PDF file, or maybe video.
Any data?
And something like a torrent, but let's see how much of the torrent we can cover. But the people can share file and other can download it. That's it.
Okay.
But with a little bit, as I mentioned, it is experimental, and then we are going to experience some patterns. Mostly, we are going to have enough space to continue. For example, I really would like to have design that easily we can implement kind of a YouTube application inside. It means you can create a channel. Inside a channel, you can create some content, and then others can subscribe and do payment for that channel, and then they can access to the content. So it's going to be a little bit more advanced for the next version. It means we need to implement subscription, do payment, or access control on data. Could I answer your question?
Yes, yes. It was mainly to just step back and get the idea of the application.
That is great. That is great. That is true. I should have done the first step. Thank you. Thank you. No question? So I would like to continue actually the design another step and then go for the pair programming actually. What is the idea behind the scene? As you know, in the DNA, we can create entry, we can implement some business rules, and you can implement your application totally inside the Rust with a lot of feature, any application you would like. But the idea behind the PeerShare that here you can, in the outlet layer, I really would like to create a one layer of abstraction. What does it mean? It means instead of creating a concrete entry for the application that, for example, first name, last name, ID as an entry, which is going to be concrete entry, and you need to build your zone and then continue if you would like to put some validation, or you would like, for example, implement extra validation and limit your first name from 50 to 80, you need to change the code, and then you need to implement a new version of DNA and go for the versioning DNA. I would like to implement a schema, JSON schema abstraction. So it means developer in runtime can create one entry as a schema definition based on the JSON. And then end user would create the schema JSON data based on this actually data definition. And then if there is any change in the schema definition, there is no need to go for version. The developer can create a new entry at the top of it. So, and there is no need to go for the new version of the application. Is that clear? I think I need also to open the JSON schema to show you a little bit. Let me also show one example. So yes. It is JSON schema. JSON schema, actually, in this URL, it is available. So it is kind of a standard, or it's making some standard that we are going to use it to validate data, and actually to validate data and a schema. So if you would like to go to see the standard here, as you can see, it is here. I should have prepared something sooner, but sorry. So easily, as you can see, you can say, I'm going to have a type like a number. So you can specify the length, you can put it's going to be exactly like a document base. Let me see if I can find some examples. I think I have something in the here. Let me open a project. I have something to show. Oh, where is it? Okay. Okay, so I found. Thank you, Guillaume. So let me continue share. So yes, as you can see here, example, it is the basic one. So look, we can easily say the title of object. It is object, the property, first name, type a string, description. And so you can say a minimum of integer can be 0. It means unlimited. It means it is okay. Age. You can implement some business rule. So I really would like to have generally this one as a one entry, that we can save this schema as a string, like a document-based system. So if we can save this schema, developer is going to implement this one. How we can recognize just one person as developer, it's going to create this entry, we need to implement Progenitor patterns. I will explain Progenitor pattern and we will implement together. Don't worry about that. So developer can create a schema. It means data entry. If you are a developer, you know SQL Server or MySQL, exactly when you open SQL Server and create table or MySQL. This one is supposed to be a definition of a table you are creating. When any entry end user would like to enter a data based on this definition, something like that, it means user is supposed to send this one. For example, it is a data, you know, it is a schema and it is data. It is a schema definition and it is data. End user supposed to send this data. Our code supposed to, at first, when developer sending this schema, we need to validate based on the version of the actually schema, JSON schema. If it is valid, it's going to be a valid document with the entry hash. When user is going to publish any data, it's supposed to say my data is based on this document entry address. So we can easily fetch this schema, and easily based on this standard, we can say this data is valid based on this schema. That's it. So what happened if DevOps, that it is our concern, we would like to change something. We would like to add last name to the document. We would like to change the validations. It means the length of a first name, it was 50, but change it to 150. There is no need. In the basic way, we need to change entry, it means the hash of DNA is going to change, and we need to go for the versioning of a DNA. In this way, nothing. Developer publish a new version of a JSON schema, and the rest is going to totally implement the connection between a data and a schema and a validation. And you will see how it's supposed to be working. Please, Tim.
But it would mean that the old entries if you imagine that you add an extra field, the old entries will not have that field. So it means that whatever is consuming that data needs to take in account that there could be two versions.
Exactly.
Okay.
Exactly. We have a version 1 here. Let me see, like always, that I can go to drawing. So the things that instead of taking care of some versioning and data and validation or a business rule logic inside the DNA, we are going to shift it from a hollow layer to outlet layer. If it is coming from a hollow layer to outlet layer, it means if you do some changes like a drop-down title, like kind of basic info changing or a changing business rule or a schema definition, there is no need to change the hollow layer. We just need to change the outlet layer and go for a DevOps. This one is much more easier because the DNA code is not supposed to change. But for sure, there is a limitation. What is the limitation? For the complex business rule, complex logic, for sure, because it is generic, if there is a generic pattern, we are going to have some limitation. Implementing a specific business rule for each entry, it is not right now possible. But we can think about some solution like uploading a WASM inside the entry that automatically we can run it, we can send to the WASM. So the WASM can automatically on the fly run and send the data and look at the result. If it is true or false, just can continue. It's a little bit going to be complex, but there is a possibility for the future that it's going to be a smart contract. But right now, we just accept the limitation. Jakub, please.
Right, very question, because from what I understand, then the DNA hash, which represents the kind of the unique validation rules or the hub, is one of the pieces that allow for kind of the data integrity, right? Because we know that we are using the same logic, so we have the same DNA hash. And now when we are outsourcing the logic or part of it to the schema, so we are using the hash of the schema. But how do we, is it going, like, how do the applications, how do I know, or my application knows that we are actually really using the same schema through the hash? So do we put it in the progenitor pattern and this, or yeah, how does this work?
Yes. So it is the way we are going to architect and design outlet layer. So let me see that you ask a question, nice question, which is for the future. I really would like to show you with something real, but let's see that I can find it. During the time for finding, I'm pausing the video, guys. Okay. So the question, the answer for the Jakub question, that how we can manage that if it is a dynamic schema, how we can connect the data with the dynamic schema, it is exactly happening inside the outlet layer. So how it is working, as you know, we have a different version of application. If it is a mobile application, anybody can install a different version of application, or even we can have a different version in a browser or anyway. My current solution right now is something like that, and I implemented. I didn't finish, you know. So I'm going to explain later. We are not going to start from here, but all in all, the application is going to read. It's going to, can you see? It is a controller, view, and model. So we are going to somehow detect what version right now it's supposed to use inside the application which is coming up and running. The version can be the number, it is hard-coded. It can come from URL or a mobile version or even hard-coded. So how the things happening, as I mentioned here, do you remember I told we have a different model, okay? So just imagine at the beginning, we have a model version 1. It is outlet layer, you know? Concrete model is going to be here. It means we say, hey, I have an account. The definition is going to be this one. This format should be a JSON schema format validated. It means compatible with that one. We implement this all the model of the application in this format, okay? So here we detect the version. So it's going to actually load the whole model here and try to apply model to the DNA and receive a hash of the schema. And because it is the initial stage of the outlet layer, after the application initialized, it automatically know that I applied the DNA model, I applied the model to the DNA I sent, and I received the hash of the schema. Every entry that the user is supposed to apply or inject or add to the DNA, it's going to use this address. So when I'm going to, for example, create entry like account, it's initialized and I know that the valid version is with this address. I'm sending my entry with this one. The logic code, the business rule inside the DNA automatically fetch this one and validate the data based on the injected or added schema which has been added by developer. If it is valid, it's going to be added. Otherwise, it's not going to be added. Outlet layer based on the version in URL, in mobile application, somehow it's going to be initialized and connect between schema and data entry.
Thank you.
You're welcome.
So when I have a question.
Yes, sure, please.
So as a developer, when I update the schema, I will have to. Do you store the schemas in the DNA or just in the outlet? Part.
You create a. Okay, I should have.
Not that in the DNA. Sorry, I mean in the DHT. Do you?
Let me. Yeah. Generally, I'm going to see that if it is coming up to show you a little bit UI demo, you see how the things are working. But generally, concrete data model, concrete, it means account, first name, last name, blah, blah, blah. It is in outlet layer. In the DNA, we have just an abstraction layer. If you as a developer would like to implement, you need to create our application supposed to have two sections, admin layer and a general, it means console admin and a normal panel for the normal user. In the admin panel, user would create a concrete model, and for implementing, he's supposed to create a concrete model and publish as a version of application. Let me show you how the thing is working. Oh, I missed record something, but let's actually go again to the, for quick review the DNA design, schema extract, definition, version, owner address. It is the developer address. We are going to implement Progenitor patterns. What is Progenitor pattern? This is the property inside the DNA definition. We can limit some business rules, some code that a person who has the agent public key inside the DNA property as a progenitor pattern can do something. It is exactly the place we would like to limit the application. It means only developer can create a schema. So as you can see, it is one example. Developer can send this one. So as a schema, field, title, length, something like that, or different schema. There are some examples. And we are going to have two other entry. It is the design of a DNA, public content and private content. As you know, inside the holochain, we can have two different set of entries, public entry, private entry. Public entry, it is the entry that go to the hash or DHT, go to the DHT, sorry, as a hash. So anybody can access and read the data. It is a public entry. Private entry is going to stay on your source chain. So only your footprint about the editing is going to be in the DHT. To have the abstraction at the top of it, we are going to have the two different entry, public content and a private content. Public content has a content, a schema address, and you are as an owner. A schema address, it means what is the content you are going to apply. What is the schema? What is the document definition? For sure, as we talked and Jakub asked, this section is going to implement it automatically in the outlet layer. So if you are going to add a new entry, so if DHT part of the code, it's going to automatically validate your data against this schema address. If it is valid, you can actually enter your data. Otherwise, validation rule is going to stop you. It is for a public data. And also we are going to have exactly the same as public data as a private data, because it is abstraction and generic. So public data and private data are supposed to be exposed by a ready entry. So the same logic is going to be there. It means the data is supposed to be validated against the schema address. But in that case, the data is not going to be inside the DHT. It's going to be inside your local source chain.
Have a question there. Validation rules don't really execute on private entries. So how are we going to validate that their content?
Generally, as we have this standard that for your private entry, you are allowed to do whatever you would like, you know. For the validation, we are going to implement a validation in execution. It means we have a two-part, as I'm explaining for anybody actually. We have two sections to implement the business logic. When it is entry and another one is a validation. So when you are entering your data in your local code on the function, zone function, we can implement that validation, which is valid. It is a one part. Another part, that validation rules that all other peers are going to run and validate your role inside the network. For the private entry, we are just going to validate inside the zone function. For the other validate, we are going to ignore it. Because it doesn't make sense. You can change whatever you would like inside your local chain. So, is there any question? Generally, you got the whole idea, what's happening, what's going to be happen. So, I'm going to pause and let's see. Okay, so yeah, I have it here. I can show you what does it mean when we are talking developer or a non-developer, generally to make the things clear, or progenitor pattern, which is really beautiful. We are going to use it a lot. So I'm going again to share my screen to show you. For sure, in a pair programming, we are going to implement in use case in a reality. But because right now we are in a design time or idea review, let me share what does it mean. Can you see it is a DNA YAML? We are going to talk about that. We are going to implement from the scratch, but right now you have it. Look, in the DNA YAML that you can define different zone, there is a section named properties and the developer address. So when you are going to bundle your application, so implement, you can inject any data here. When I'm talking about the developer only can implement or create a schema, it means an agent with this public key. So we can design the public private key based on the developer. Developer is going to inject his own or her own public key here. So inside the code, using the Progenitor pattern, the name of pattern is Progenitor. So we are going to read a developer address. If any schema entry is going to be submit, we are going to validate against this one. It means who is going to submit the entry? So it is the public key. Oh, what is the public key inside the property of a DNA? Is it equal? Yes, you can enter a new schema. Is it not equal? Oh, so sorry, you're a bad role, bad agent, or bad actor actually inside the network. So maybe somebody asked, so what if I change this property? If you change this property, the DNA hash is going to be changed and you are not a part of network anymore. That's it. It means you can, if you want to play with others to be inside the one network, you cannot change property by yourself. It means there is no way you can cheat it. That's it. Did you get the general idea about the developer? What does it mean, Progenitor? Who is developer? How we can distinguish between end user and developer? Is there any question?
Well, question, comment, I don't know. Have you thought about not having only one progenitor, but having some kind of roles-based thinking, which the creator of the app can delegate DevOps roles to other agents so that he's not the only one, things like that?
I did a little bit, not a lot, but I don't think we need to expand the logic of a progenitor. It means progenitor is going to be there. We need to implement some entry that the entry can be just edited by progenitor. It means we are going to have some role-based entry and the progenitor can add some public key or private public key or some others and grant the permission. As far as they are there, they can do something, otherwise no. It was a little bit, but I didn't think about it deeply or provide some solution.
Right, maybe the membrane roles module from Holochain OpenDev fits that. I think it does.
That is great.
It also assumes a progenitor.
That is great. That is beautiful. It is the way we really would like to experience modularity. You know, it is one of the things we are going to just experience, to reuse some module, actually external module. Any other question, guys? Please.
Perhaps, Hidayat, how do you see kind of the first hands-on steps? Do we have some scaffolding repo, or do we create?
I did. I started actually about the DNA part. It's kind of, I can say that close to finish, but not really. But I really would like to start it from the scratch by pair programming here. But I don't know why my expectation that we can start pair programming also from today, but I think it is not a good idea to do it today. And we are going to go to start the implementation and pair programming from the next week. But there is, yes, I can share with you, but step by step, I really would like to bring by pair programming here. If you ask me to share the GitHub repo, I can share, yes.
I have a question that's not clear for me. If you know you're running an instance of PeerShare on your PC or Mac, how, if I run it on my computer, how do we connect and authorize each other to form a peer-to-peer network? And if I don't want some third person to participate, how do I refuse him?
I talked a lot. Guillaume, would you like to go for this one? Or others, please?
Does anybody? Lucas, are you talking about PeerShare specifically or in general Holochain applications?
I mean, I know the abstract principle on how it's supposed to work with Holochain, but I don't know concretely, now that we have this actual project in front of us, how do we handle this? Is it will it be in the UI? So it's not a theoretical question, more of how do we do it hands-on?
Right. So PeerShare is trying to target Holo. Holo is. Do you know about Holo more or less? Yes, sure. So with that, we are going to run the PeerShare Holochain app in other people's HoloPorts, right? And in other people's HoloPorts, there are conductors, which is the Holochain node running with the PeerShare app. And then different HoloPorts connect together via Bootstrap service that Holochain is running. Then it's something like this. Some HoloPort boots up with our application and connects to the Bootstrap service and says, hey, who else is running this application? And the Bootstrap service says, I don't know anyone who is right now. But then another HoloPort boots up and then he talks to the Bootstrap service and the Bootstrap service says, yes, I know another Holochain node, and they interact with each other and now they are connected. And basically that's the same process, but maybe thousands of nodes, something like that. And then not every node knows every other node, they just know, I don't know, 10, 20, 30 nodes on their environment. So that's the first step is this bootstrapping service, but after that it's all peer-to-peer.
Yes, so the validation is handled by the HoloFuel app or the Holo app. So
not
the validation
exactly.
of the peers, I mean.
Right. The validation of the peers coming, that would have to be done via membrane. So there is a special validation rule that you can put in every Holochain app that is basically validate agent, which agents are valid to enter the network or not. So it's not HoloFuel app, it's not Holo as a network, it's actually the Holochain DNA that we built that we have to define that. And then if a malicious node tries to enter the network, then everyone can run the validation rules and say, hey, you're not a valid agent here. But that's actually a good question, I think, for in the future. What do we do in this generic application as far as membrane goes? I don't know. We have to think about it.
Did you get your answer, Lucas?
Yes, but I would have another question then, which is, is it intended to have both our own Holochain node network and the Holo network? Okay, if you see, I don't know if it's clear.
So actually, in an interesting way, there is no separation. An application running in my computer can connect directly with an application running in a HoloPort, and there's absolutely no difference between the two.
That was what I wanted to hear.
Yeah, nice.
One notice here, you are supposed to run both the same version and hash of DNA. And it is the topic about the progenitor I mentioned. If somebody change even the small character inside the DNA and hash, you are not part of the network with that one, you know? You are totally in the new world. You can, or agent can continue live, but in the standalone network. That's it.
One question, I'm not sure if I understand this right. Like, okay, if you change the DNA, it's different hash, so you're on different networks. But if you were talking about hApps, like DNA bundles, if I were to add one extra DNA, then all the other DNAs would still keep their original DHTs, no?
As far as I know, yes. If you have a new application, you bundle the different DNA. If there is another application that with a different set of DNA, but as far as they are the same about the hash, they are going to be inside a network.
Yeah. So you could, in principle, you could have a version of a hApp with 5 DNAs, and then next week release your next version of your hApp with 6 DNAs or 4 or whatever you want.
A concrete example can be profile. Just imagine you can design a DNA for a profile. So you can inject the profile inside a different application with a different bundle. If the profile is going to be the same logic of the profile is going to be applied inside the application A, B, C, you know, it's kind of a single signing that always we think about that, because the DNA exactly the same, the behavior is going to be the same inside any application bundle.
Okay.
Any other question, guys?
Yeah, I'm just, but it's more like a thought experiment, and it's deviating from the thing you're trying to do. But I'm just thinking if there would be an alternate way to make this work, using this principle of you have instead of putting your new data schema inside an entry, to put your new data schema inside a new DNA. But it's like, I'm not sure how that should work, but could be like a more holochain-like way to solve the problem, or it could be more it could be more difficult or more complex, but as a thought experiment. But that's perhaps more for in the forum to talk about that.
Sure, this is a nice idea. Also, there should be enough benefit about that, because as much as we expand the abstraction, you know, abstraction brings limitation. When it is abstracted layer, nobody knows how to deal with the things that we don't know what is that, or how to deal with the membrane. So more abstraction, more concern. So we are almost 1 hour and 15 minutes. So yeah, I didn't expect this kind of, yeah. I was thinking that we are going to start pair programming. So yeah, I was ready for that, but today, no. We are going to officially start next week implementing the DNA design. I can also share my repo. I'm going to migrate my repo to the Holochain-in-Action official repository GitHub, that because I think maybe in the future we are going to implement other things, or maybe anybody can bring idea. We can do pair programming here together. You know, it was the main idea to knowledge share, to implement the thing, a small, big, something like that. So let's do pair programming from the next week. So from the DNA design, implementing tests, and start from the scratch from the next week. But if you go to the repository, I didn't finish anything. As I mentioned, I don't know. If you ask me how exactly you are going to implement the thing, I would say I don't know right now. I just know how the things are working and how it's supposed to be. I don't know. we are going to figure it out together, actually.
And do we have a common space for sharing, like a subforum or a Discord? I don't know.
Yes, actually, we have inside the forum, we have a section for the Holochain-in-Action. I'm going to upload the video or about the PeerShare there. So let me also share. It is here. So I'm going to stop recording. Thank you, anybody, for watching, and see you next week. And for the people who are watching, bye-bye. Maybe we are going to do a little bit more extra here, unofficial. Bye-bye, guys. See you next week.
Thanks, Adayat.